Graph the inverse of the following function. All right, in order to graph this function, we basically need to think about a couple of things. First of all, we haven't been given much, right? We're basically given an image, and we might have a couple of points there we can identify, but outside of that, we haven't been given much. So what I do want to mention is a couple important details. The first is that a graph of a function and its inverse are always symmetric with respect to the line y is equal to x. So if you were to actually plot that, let's do that with sort of a red dashed line here, So let's say that's the line y equals to x. That's basically what it looks like. It's a diagonal line that sort of chops the rectangular coordinate system in half along that diagonal. This graph is symmetric with respect to that. That means if we were to sort of fold it over itself, right? So fold the rectangular coordinate system along that dotted line, we could basically plot the inverse by just tracing what we would see, right? So basically, if you did that, you might see something along the lines of this, right? Something like that. So if you folded it over, wherever it laid on top of the other side would basically be where the graph of the inverse is. So that's really helpful. That can almost graph the thing for us without doing anything else. However, we can also make use of this idea, which is that the domain and the range switch for these two functions. So f and its inverse have the domain and range switch for one another. In other words, the domain of f is the range for f inverse, and the range of f of x is the domain of f inverse. All right, so either way, with that in mind, it basically means that the y and x components of any points switch, right? So, for example, I think this point here that we were looking at, I think you could identify that point as 1, 2, right? And I think this point here can be identified as 0, 1, right? So that must mean that on our inverse function, we can graph a point 1, 0. And I can say that that will be on the function because 0, 1 is on f. And likewise, it looks like I should be able to say that 2, 1, so 2 over and 1 up is also on my graph because, again, 1, 2 is on f. And if we just switch the x and y coordinates, then we should be able to get a point on f inverse. So 2, 1, and here we have the point 1, 0 because those are sort of the inverse points of the points we can identify on our graph. All right, from there, then basically all we need to do is sort of follow that inverse idea and say, look, it looks like the graph should curve then, if it's a mirror image across that dotted line, it should curve something like that because that's what it's doing kind of in the mirror image on the other side. And likewise, down here, it should sort of hug this line here, this negative y-axis. If you notice, the black graph is hugging the negative x-axis, right? And so we expect that the blue line will hug the negative y-axis, right? Because that's basically the same idea of switching x and y, right? And again, you can also see it because if you look here, there's this distance that can be connected between these 2 points. These are like the same distance, right? So likewise, a point, for example, from here to here is about the same distance away from this red line, right? So again, we have that sort of symmetry idea going on. So that's basically what the graph would look like. That's our best guess, based on the limited amount of information we were given. Our drawing in blue represents the drawing of f inverse, if the black drawing represents the drawing of f.